Okay. So can someone tell me what were the things that we have discussed last time in a very short synopsis? Ano yung ating mga na-discuss last time? Christine, do you have any Christine, do you have anything to share to the class if in case? Ano yung ating mga things na na-discuss last time based on how you can recall them? Christine, wala. Madungog ko ninyo class?
Yes,
Yes,
Doc.
po, Doc.
Yes, sir.
Sige. Ma'am Christine, nakamute ka yata. Ano yung ating na-discuss last time?
So for Doc, sa kanina duman ang na-discuss na to is about atong sa katong pag-run sa Weka, or pag-install sa Weka, tapos katong mga machine learning Doc sa na nahisgutan is katong i-present mo Doc ang katong imong study na nagamit kag machine learning.
Okay. Sige.
And then ipaano minimum mag-discuss kani o katong sa Google Doc na mga
Google dataset. Oh, correct.
dataset.
At least you have already seen, na-finalize mo na ba yung example mo, no? Yung domestic violence in Colombia?
Opo, Doc. I-send ko sana sa iyo ngayon pero alam ko may klase so hindi muna.
No worries about it. There would be a time siguro, since face-to-face naman tayo next Saturday, no? So there would come a time that I would go to you one by one and discuss each of you will have to discuss your data set to me and your proposal to me in 5 minutes. And then we're going to agree kung anong specific algorithm that we're going to run. And I would give you some resources so that you can explore it. So thank you, Christine. And the last time we were able to at least go over the examination questions, no, especially in the prediction of values, in the prediction of regressants based on given regressors. No, we have examples that ranges from housing prices in Paris, and we have wine quality. We also have also discussed several things about regression analysis that utilize the hackathon dataset. No? Nag-emphasize din tayo doon kung ano dapat ang considerations natin when you do predictions by looking at the normality of the dataset. Now, since half of the class last time was intended to introduce to you the installation of the software, it is but right that we were going to discuss the things that led to the development of the Weka software and its graphic user interface, or GUI. So this morning, we're going to discuss Weka intensively. What is it? Its history, the Weka's graphic user interface, the old and the new, so that you would be aware of the current changes of the software, the user interface, or how it looks like in your computer. Basically, the one that you have installed is the latest version, which means that the latest version now is not the version that I was accustomed to use in 2018 and 2019. So parang kakabago lang talaga nila mag-launch kasi when we do our staff work para sa project namin on Goddess, what happened is they have the interface is quite different, but not really different, not really totally different, but the graphics is really different. And then what would be the impact of the development of Weka to data science and predictive analytics and projects that you can use, and the features of the user interface, and plans for the future, especially in terms of research and development. So as I've mentioned, Weka is a bird in New Zealand. I guess it's the national bird of New Zealand. So apart from being a bird, it's also an acronym. It stands for Waikato Environment for Knowledge Analysis, considering that this was developed by the University of Waikato. So Weka is a software, or Weka as a software is a collection of state-of-the-art machine learning algorithms and data processing tools implemented in Java. So it's very important that your computer has updated its Java component, because if in case wala kayong Java installed in it, or if in case you have a problematic laptop, then Weka will not run unless your Java is updated and it's released under the GPL. Now, a little bit of emphasis for machine learning here. What do you mean by machine learning? What is its different with human learning based on how you see it, no? Nakita natin na ang human learning is complicated, no? So, ang ating brain is actually the one that does the learning based on impulses and based on the stimuli around. It could be stimuli that is it's actually shaped, or it's actually the stimuli that is felt, or the stimuli that are felt, manifested, or learned by our receptors of our organs or our system. So for example, if in case there's so much heat or so much pressure, then the skin can actually, or the integumentary system can actually detect it, because there are specific receptors that send signals to our brain. The brain actually interprets that as parameters related to heat, related to pressure. It provides specific decisions based on learned examples in the past, and there would be a decision to immediately withdraw yourself from that source of heat or that source of pressure. So akin to that function of the brain or the human learning comes machine learning as it applies to our computer units. Now, the computer set that you have, or the computer unit, or the personal laptop or desktop computer that includes specific programs, especially if you install Weka in there, which is a machine learning software, would actually highly depend on your current data set, your big data, the current data that you have, and learn from the patterns in it. So akin to the brain, the computer would actually study the pattern of your data in predicting or classifying something, and it would classify future data sets or future instances that would come in based on previous learned patterns. No? So Weka provides support for the whole process of experimental data mining, because there's a particular module in Weka that is called experimenter. No? So you can click on that if in case you want to do default experimentation of machine learning. But our focus would be on the starting, no, ng pinaka-basic talaga na machine learning talaga, para at least magamit nyo talaga if in case. You can do a lot of explorations in the future if you want to do experimenter. Okay, so what would be the things that are incorporated in data mining? That includes preparation of input data. When we say preparation of input data, that includes the processes or steps that are akin to data cleaning, data wrangling, feature exploration. When we say feature exploration, you're going to identify which of these variables are valid in consideration of your dependent variable, kumbaga. So for example, if loan default ang pinag-uusapan natin dito, categorized as 0, which is non-defaulter, and 1 being defaulter, ano dito na mga data sets are considered to be the features necessary in the prediction of that. Baka kasi may mga data, meron tayong mga variables dyan, like purok, na wala naman nagmatter. Purok, zip code, na hindi naman talaga nagmamatter in prediction of your loan default, something like that. So that's called feature exploration. So apart from it, we do exploratory data analysis, or EDA. So that includes identification of possible outliers, possible misencoded or mistyped or misrepresented na mga data or instances. That also includes missing values identification. So all of these preparation of input data can be classified as unsupervised machine learning approach. Okay, because your approach for unsupervised machine learning basically is on the instances or the quality of your data sets prior to the modeling, which is under the realm of supervised machine learning. So another one is statistical evaluation of learning schemes. Before anything else, Ms. Jonathan is here, right?
Yes, Doc.
Okay,
Good morning.
I perfectly remember that you did a computational statistics as your major in MSU. Is neural networks part of your discussion back then?
No, Doc. Hindi kami umabot dyan, Doc.
Ano yung mga specific mga machine learning na na-cover ninyo back then?
Wala pa, Doc, sa machine learning na part because
Wala.
nag-focus ako sa ending sa theory, Doc.
Okay, sige. So part of our considerations for computational stat is more of learning from the patterns of the data set. No? So those are covered under, thank you, Jonathan. Those are covered under the preparation of your input data, and then you do the statistical evaluation of learning schemes. Itong statistical evaluation of learning schemes is looking on specific algorithms that could study this particular data set. So last time I was able to give you a quick demonstration of IRIS dataset when you wanted to classify whether the specific classification as venticolor, setosa, and another one, it's predicted by measures such as sepal length and sepal width and petal length and petal width. So the choice of the algorithms that you're going to apply for it would actually contain specific statistical outputs such as but not limited to F-measure, accuracy, precision, recall, and confusion matrix. So all of these are statistical in nature. And you're going to apply it in order to understand whether the algorithm has correctly classified this particular species into how theory has dictated you to classify them. So if in case na ganito yung sepal length and width at saka petal length and petal width, and then theory states that it is setosa, this is iris setosa rather than iris venticolor, then that means that your algorithm would be evaluated whether it was able to capture that information. Okay, because your data set would not tell you or would not tell you automatically that this is it. This is correctly the thing that you have identified is really correct based on how you predicted them. So it would be you looking on statistical evaluation processes that are part of the output of your machine learning. And finally is the visualization of input data. So the last time I was able to demonstrate to you quickly kung ano ang magiging itsura ng decision tree. Diba? So makita nyo dito may mga branching doon. So this morning, we're going to re-execute that so that you would know how to do it if in case you are requested to run a specific analysis. So ang ating dataset talaga na gagamitin ngayon is more of iris.arf. So again, it's .arf because Weka is saving datasets in ARF files. Okay? So, ano yung main features ng ating Weka dataset? Main features, pag may mga missing values daw, pwede rin ba marun or need to put in? Okay, so that's a very good question. No? So, as part of machine learning, hindi lahat ng missing kailangan mong palitan. So, siguro, if in case, as I've mentioned, if in case there are, the dataset would not exceed to more than 25% of the missing values. And then if in case napaka-huge ng dataset, baka pwede pa yan i-consider natin. No? Pero if in case na ang missing values, ipagpalagay natin 1,000 yung instances mo, tapos ang missing 900, do you think you need to do the modeling? Parang hindi na yata. No? You may want to exclude that particular variable. So basically, it would seem to look to be like that. No? So ano yung main features ng ating Weka software? That includes 49 data pre-processing tools. Ngayon updated na ito kasi meron silang mga dinagdag na mga algorithms. It has at least 76 classification or regression algorithms. So yung regression na ating nalaman na ordinary least squares, isa lang yon. That's OLS. Hindi pa natin inestimate ang fixed effects, random effects, hindi pa natin inestimate talaga yung ating stepwise, forward, backward, hindi pa natin yun inestimate. Yung normal talaga na regression is the simultaneous ordinary least squares method. Yun lang po yung algorithm na nira natin usually sa SPSS. But in Weka, it contains 76 classification or regression algorithms. Okay? And then ano bang pinagkaiba? Kasi ang classification would also use the regression algorithm, but it's a different regression. It could be logit, it could be binary, it could be multinomial, or it could be ordinal, depending on your dependent variable. But if in case continuous ang ating dependent variable or ang ating response variable, then the regression algorithm is applicable for it. Now, we also have 8 clustering algorithms. I would show you later kung ano yung ating data preprocessing, classification, at saka clustering. We also have 15 attribute or subset evaluators. It would be best to check whether the independent variables or the regressors would somehow be somewhat correlated or covariated with them. So ang ginagawa natin usually sa ating SPSS or sa ating normal na approach is we do Pearson product moment correlation prior to the regression. But in Weka, it doesn't compute that. No, it computes the relationship or association by means of subset evaluation or attribute evaluation. So meron tayong 15 attribute subset evaluators, meron din tayong 10 search algorithms for feature selection. So ang feature selection natin is identifying variables that could actually be a correlate or something that would associate to your dependent variable. It also contains 3 algorithms for finding association rules, 3 graphical user interfaces such as the Explorer, Experimenter, and Knowledge Flow. I'm not so sure if 4 na ngayon, but these are the usual default. Ito yung ating ginagamit talaga, which is the Explorer or the EDA environment. Now, the software was funded by the New Zealand government since 1993. So the goal of the program is to build a state-of-the-art facility for developing techniques of machine learning and investigating their application in key areas of the New Zealand economy. So economic ang reason kung bakit ginawa yung software in order for them to study huge data set on a faster and more efficient way compared to the algorithms that are statistical in nature. So since statistics is mathematics in itself, then they have actually argued that it would have a limitation, especially on identification of patterns that are not mathematical by nature. Hence, machine learning was birthed as a concept. So it specifically creates a workbench for machine learning. So the workbench in there is the user interface, basically. Determine the factors that contribute towards its successful application in the agri-industries and develop new methods of machine learning and ways of assessing their effectiveness. Itong ways of assessing their effectiveness is something that we usually forego or skip or not consider in the actual statistical approach. Because sometimes, especially kapag social sciences, we are always limited, or our focus is more of interpretation of significance based on p-values or probability values. We do not usually care whether the data set is normally distributed unless otherwise your panel is highly particular with that. No? If in case atong correlation ba nato is tama ba ang atong pagka-reverse coding, if in case ang variables natin would somehow matter to the analysis, sometimes we do not watch those. No? Ang atin lang is masagot lang natin ang statement of the problem. But in machine learning, it's not more of testing hypothesis. It's more of looking whether or not the algorithm is sufficient to create a pattern that is interpretable based on reality. Because then again, our assumption as statisticians would be all models are wrong. But then some models could be right, especially if in case you can deconstruct them to reflect social realities. So kung ganyan, kapag ganyan yung intention natin, it is just but right to assess whether the statistical models that we have say something or actually reflect the reality. One good example of measure of assessing effectiveness is R-square and adjusted R-square. Now, based on our previous discussions, what would be the difference of an R-square and an adjusted R-square? Can I ask Ma'am Emily Las Piñas? Ma'am? Ano kaya ang difference ng R-square and adjusted R-square?
Good morning, Doc.
Morning.
As far as I remember, Doc, R squared refers to the fitness of the model, or shall I say the percentage of the influence of the independent variables to the dependent variable.
Ilang independent variable ang nasa kapag R square ang ini-estimate natin?
R squared R squared, I think one independent variable. You're asking of the independent.
Yeah, ilan yung independent variable sa kapag R squared ang ini-interpret natin?
Isang independent variable, Doc. And for the
Okay,
adjusted,
adjusted R square
for the
is?
adjusted, we have 2 or more.
Okay, 2 or more. But in multiple linear regression analysis, or where a specific model contains more than one independent variables, both of them has to be interpreted, though, the R square and the adjusted R square, because in adjusted R square, it accounts for sensitivity of the possible variance of two variables. Kung isang independent variable lang, it would basically be just estimating the magnitude of a determination, that coefficient, it's a coefficient of determination. It basically explains the impact of one variable to another variable, then that's R square only. But if in case adjusted R square, yung dalawa yung ating interpret. So we interpret that as ranges, so because usually yung ating adjusted R square is smaller compared with our your adjusted R square is smaller than the R square value. Now, going back to the history of Weka, it was developed as a state-of-the-art workbench of data mining tools. It's not something that would give us probability values. Napansin niyo siguro sa ating mga output last time na wala akong dinidiscuss na reject the null hypothesis because that's the realm of social sciences, application of statistics for social sciences. In machine learning, we do not care about it. We care about the fitness of your model more than the probability. Okay, and then explore fielded applications and develop new fundamental methods. Now, in late 1992, the funding was applied for by Ian Witten, the one who actually developed the software. And then by 1993, they developed the interface and infrastructure. The Weka acronym was coined by Jeff Holmes, and Weka's file format, or the ARFF, was created by Andrew Donkin. And fun fact, ARFF was rumored to stand for Andrew's Ridiculous File Format. So basically, that was the extension. Yung .doc, mga ganon, .sub, .csv, may mga meanings yun. Kumbaga, sa CSV is comma-separated values. Ang .doc is document. Ang ARF naman was Andrew's Ridiculous File Format, accordingly. And then sometime in 1994, the first internal release of Weka was done in University of Waikato, and the user interface was based on TCL and TK, plus the learning algorithms was mostly written in C. So right now, it's kind of different because it's highly dependent on JavaScripts. Okay. In October 1996 was the first public release of Weka. That's the version 2.1. And since then, nasa version 32 na tayo, if I'm not mistaken. Now, on July 1997, Weka 2.2 was released, and there are new schemes that support for C5, and they included a facility based on Unix makefiles for configuring and running large-scale experiments. So, noong una, yung Weka can only accommodate small data sets, no, or data sets that are in the thousands only. But since their intention is more of applying machine learning to big data, because their argument was that if in case your data set was very large, then you can create meaningful pattern out from it. And such pattern is reflective of the population. Kasi kung konti lang yung sample mo representing millions, then the coefficients that would come out would be doubtful as to its representativeness. Okay, so in early 1997, the decision was made to rewrite Weka in Java, and such proposal was originated from the code written by E.B. Frank for his PhD. And originally, it was codenamed JAWS software, that is Java Weka System. But basically, they retained Weka for nationality purposes. Okay, so meron dito mga specific events in 1998 and 1999, and that's the improvement of the graphic user interface of Weka as it is worked together or in conjunction with the release of the data mining book that is used as a user's manual. So back then, this was the particular interface. So, hindi naman siya masyadong nagkakalayo sa ginagamit natin ngayon. But then, there is that particular interface sa baba that includes the specific steps that you do. Ay mga na-load niyo ba ang software? If in case may algorithm ka ba na ginagamit, ano yung mga movements doon, ano ang mga movements mismo sa interfaces nakikita mo dito sa system log. But then, such system log is akin to other software. Parehas lang kasi siya sa ibang softwares. That's why its originality was put into question. Baka copycat lang ito ng something. So later on, the system log feature of the Weka 2.1 was eliminated, and this was retained, and the modules on top were actually kind of different or kind of incorporated into just one specific function. So ito yung ating attribute editor. Yung attribute natin is called a variable. Yung variable in Weka that is called an independent variable in Weka it's called attribute. So responses are called instances. Okay? So ngayon, eto na yung ating Weka, no? It's basically giving us a little bit a refresh, it's a breath of fresh air considering na meron tayo, we can do some colorations in there, we can actually classify them according to different colors and according to different class attributes. So you can see all the variables, you can edit the variables, you can do everything, but all of the things that you can do here is incorporated only here in the pre-processing section, and the algorithms are later added as different modules. So this one contains the algorithms for classification or doing some cluster analysis. Classification, that means we're doing supervised machine learning. For cluster analysis, it's already here. Association, selecting attributes, or the feature extraction and visualization. All of them are actually embedded here as different modules. So, as a hint, what we're going to do is review the types of files that can actually be imported here in Weka. So we have the ARFF or the ARF file, the CSV, the C45, and the binary file. But the most or the easiest files to handle are CSV based on experience and ARFF. ARFF kasi hindi ka pwede mag-encode niyan. No? You cannot manually encode something in ARFF unless you do it on an ARFF editor. But files that are ARFF in nature can actually be edited using specific na mga softwares like Notepad++ or text editors. You can do it, no? You can actually right-click and then open using Notepad or open using text file. CSV naman is Excel-based, it's Lotus-based, and you can actually save your you can actually do the encoding and data processing in Microsoft Excel and save it as a CSV, delimited file. Now, data can also be read from a URL. That means that if in case data are presented in tables or downloadable files in CSV or Excel file from a specific website, you can actually download it and call that particular file by including the URL of that in your command, in your command area or in your interface area. So you can call it by using the URL or from an SQL database using JDBC. Pre-processing tools in Weka are called filters, hindi yung Instagram filters na ginagamit natin. But pre-processing or unsupervised machine learning are filters, considered to be filters in Weka. So Weka contains filters for discretization. That means continuous data, you're going to make them discrete. So for example, income, you just bracket them and present them as one category. So that's discretization. Normalization is harmonizing or making large variances of different types of variables into something that is easily workable when you normalize them. Resampling, that means kapag kulang yung ating sample and we wanted to address issues of class imbalance. Ano yung class imbalance class? Meaning to say is if in case 1,000 yung respondents mo, tapos majority sa isang classification, for example, for defaulter, hindi naman siguro lahat ng mga nasa database mo nag-default talaga, no? So majority of them could actually comply or pay their loans on time. So may possibility kasi na more than 70% more than 70% of the data of your data set would have a class of 1, 0, and that the other 30% is 1. So klaro doon na medyo hindi balance yung ating dependent variable, which is a binary variable. May possibility din now sa 1,900 din ang non-defaulter, ang 100 ang defaulter. So klaro kaayo, it's really obvious na meron tayong class imbalance. And class imbalance is a little bit of an issue when you do your machine learning predictions, and it can be addressed through resampling. So ang 1,000 ninyo na dataset, mahimo na siyang 1,600 using a specific algorithm. For sure, tinuod ka sir na 1.6 na siya afterwards, or 1.5 na siya afterwards using a specific algorithm. Yes, no, I've utilized that to address class imbalance. Okay, so attribute selection, so makita natin siya using specific algorithms or filters. Under the exploratory data analysis, titingnan natin kung ano ang mga variables na in a way mataas ang correlation sa ating dependent variable, akin to Pearson R. And attribute combination. So mag-data engineering ta, may possibility kasi that you can multiply this variable and variable as it interacts or as an interaction term, but we're going to skip or forgo this one in Weka because we're going to do that in moderating effects in SPSS. So for Explorer, this one includes the model building or the classifiers na nasa ating Weka interface. So classifiers in Weka are models for predicting nominal or numeric quantities. So kapag numeric ng ating dependent variable, continuous yung ating dataset, regression ang para dyan. Kapag nominal naman, it could be binary, it could be ordinal, it could be multinomial, no? So ang gagamitin natin dyan is a classifier. Okay? So implemented schemes include decision trees and lists, instance-based classifiers. We have SVM or support vector machines, multi-layer perceptrons, logistic regression, naive Bayes or Bayes nets. No? So we're going to run all of this now so that we can evaluate which particular algorithm is better in terms of predicting the iris na species. And we also have meta classifiers that includes bagging, boosting, stacking, error correcting output codes, and data cleansing. So for this class, I'm going to discuss only the normal classifiers so that you would appreciate its application later. Okay, so na-run ko na ito. Ang gagawin natin is i-run natin ulit, and we're going to apply different algorithms in here. Okay, so tingnan ko muna ang following slides. Basically, na-run ko na ito. So ang gagawin natin is we're going to open your camera and open your Weka software. Laboratory session man tayo. So kindly open your camera so that we can see each other and I can see you working. Okay, can you see my unsa? Can you see? Alaka na. Kita man niya akong thesis. Akong thesis. Akong thesis, nakita. Oh, nag-MS Economics magkukukaroon class. No? So medyo nagatrabaho ko sa akong thesis. So may kadali lang. Nakadali lang. I-exit sana ko ni. So ako ang thesis di ay kay related sa machine learning pod, no? For economics. So, ako sa i-exit. Daghan naman din ako naka-open nga programs diri, right? Okay, so as I've mentioned, kailangan ako sa i-exit ka dali. Uy, ano man ni? Kadaghan ba ni? Ang dali lang, nataranta ko kadali. So as I mentioned, this is your Weka software. Ani ba ang inyong user interface? Makita ninyo? Or lahi pa siya? Katong comical ba siyang Weka?
Ngana siya, Doc.
Ano, Doc?
Ani na siya. Dili na to siyang katong cartoon character nga langgam. Dili na siya. Sige. So as I mentioned, itong tatlo isang basic noon sa first version but meron na tayong workbench and simple CLI. Now, what we're going to do is we're going to click Explorer. And then we're going to load the R file. No? So loading the R file is done in the pre-process feature, in the pre-process na module, and you click Open File. Now, if in case ang dataset mo is coming from a website, then you can actually open URL. If in case it's coming from the database, then you open database. And you need to connect the database to Weka so that it would be connected and ilabay niya ang file from that database to our user interface. But for now, we assume na ang ARC file sa inyong downloads. So what we do is we open file, make sure na nakaselect si ARC files. Otherwise, kung CSV ang inyong file na i-load, use CSV. But for this example, we're going to go to our file. Hanapin natin si Iris dataset. We click open. And there you go. Okay, 30 seconds to 1 minute. Kindly load the software. Again, it's open file. Baba sa tamo diri. Hindi man ako ni ayan. Okay. Ayan. So makita natin dito na may colorings kayo sa class ninyo. So itong color blue represents a different class. The red represents a different class, and this one is a different class. And it was, kumbaga, this one is a histogram for sepal length. This one is for the sepal width, petal length, this one, and the petal width. Okay, so these are different bins based on values. These are different bins. So make sure na nakaload din ng ating attributes here. We have the sepal length. The sepal length is a numeric type of variable. The minimum is 4.3 centimeters, the maximum is 7.9 centimeters, and the mean is 5.84. Standard deviation is 0.83. For the sepal length, makita ninyo class, no? Sepal width, petal length, petal width, and the class. So, naabatay, based on this class variable, naabatay class imbalance or wala? Is there class balance or class imbalance? Jillian. Class balance or imbalance?
Based okay, wala. They have 50 counts responses for each attributes.
Balance or imbalance?
Balance.
But of course, no, obviously balance ka 50-50 man na sila. Ang klaro kayang class imbalance class is, for example, 50 ni siya o niya 5 ra ning isa o niya 5 ra pulo ra pud ning isa. So usually it's 20% or kada gani basta makita nimo nga layo gid kay siya o gintang. Has kayong layo so for example 900, 100, 600, 200 lagi kay siya gintang. Pero kini siya class balance ang tawag ani, no? So these are naturally gathered. No, these are actually 50 kabuok na species measured according to sepal length with petal length and petal width. So since nakita nato na asya class balance, makita nato na walay missing values. Sir, how do we detect if in case anong klase siya na variable, ano yung kapag may missing values? You look at the missing 0% here. So as you can see, walang missing values for class length, wala naman sa petal length, petal width, sepal width, and sepal length. Okay, but later on, magkuanta og example nga na missing values para makabalo mo unsaon siya paghulip, no? Unsaon siya pag ginatawag nato og replace missing values. Now, having said so, na may kompleto yung ating dataset, what we do is check whether or not there are anomalies. Kung makita natin, wala naman ng missing values, okay naman ang mean, okay ang standard deviation. So I guess we will proceed to classification. Bakit siya classification? Kasi ang class interval natin is nominal in nature, different siya na species. So of course, ang gagamitin natin is a classifier, and that's here in classify. Okay, by default, we have a 0R classifier, but then we're going to run 3 different classifiers for this morning. So before to the selection of the classifier, I'm going to explain to you what is training set, what is applied test set, what is a cross-validation, and what is a percentage split. Okay, so ano ang training set natin? By default, ang ating data set is training set. That means that your data set that you have now is trained. Kumbaga, kanagay mo ni siya ang data, the software will train this data set so that it can learn its patterns. Okay, so murag diha niya tun-an ang iyang data set. Now, if in case ito yung naka-check, that means that your training set or your data set is just training set. Wala kang test set. That means that wala kang testing na gagawin. If in case na supplied test set, it interprets that your data set is a training set, but then you're going to you're going to add another file so that it would be used as a test set. At ganito kasi ang rationale niyan, class. Ano ba ang rationale ng training and testing? Ang training is it's going to learn from the patterns of this training data set or this data set so that it could apply what it has learned to another file or another sets of respondents and apply whether unsa yang na-learn diri is tinuod ba diri dapita, no? So ing ana na siya. So for example, kung mag-prediction ka o makapasar sa board examination, ang basis nato are past performances of board exams by previous students. Kanang incoming students karon nga mag-take sa board exam, unsaon na mo pagkabalo kung kinsa ang makapasar ana bisag wala pay board exam, ang gamito namo is ang kanang old nga data set as the training set, and the incoming nga mag-take is the test set. Whether or not the prediction that we do in the past is consistent to the prediction that we would be doing for the future. So ang buhaton namo ana is kining supplied test set approach. Na kay training data set, unya mag-supply kag another file for the test set. So this one is a little bit tricky, especially kung may mga meron hindi tayo techie in this one, because it could be possible na hindi consistent ang formatting ng file mo. So we're going to skip that one for later. Ang ating sunod is cross-validation. Ang cross-validation class is good for huge data sets, millions or hundreds of thousands, because you're going to do the simulation by dividing your training set into different folds. So which means na kung 1 million ang imong data set, kung nakakay cross-validation nga 10 folds, i-divide na niyag na pulo kabuok, it has to divide to that, and then after dividing it is mag-conduct siya og training and learning and training kada fold. Ngunya computer niya ang average na value anang napulo. So mao na siya ang cross-validation. That means na tan-awon kung kining 100,000, kung kini ang result, ang to another na pod nga 100,000 consistent ba, so that we can check that the algorithm is consistent as a whole and as parts. So mao na siya ang cross-validation. Sir, 10 lang ba gyud ba ang cross-validation? Ang default nato gyud class is odd numbers. So, of course, ang default nato is 3, 5, 7, 9, 11. So, ato ang iana. Pwede pa, sir, pwede ba, possible ba, sir, na we can run it in different folds? Correct. You can run it at fold 3, fold 5, fold 7, fold 9, fold 11. Sir, how about 10? Pwede ra? Pwede man siya, but gina-encourage good nato na odd numbers atong folding. Okay? So that means, sir, lahi ang result for folds 3. Lahi pod kang 5, lahi pod kang 7, lahi pod kang 9. Yes, and you're going to present them all and do some comparisons, whether or not consistent ang result sa foldings. The reason why we do cross-validation is for us to check whether our training is consistent even in the folding. Okay? And then for percentage split, mo ni akong pinakaganahan. I-divide ang data set for training, the rest for testing. Okay? So, ang pinaka-common nga rule is 2/3 ang training, 1/3 ang testing. That's why 66% of your data set is for training. The other one is applied for testing. Why would you do the testing? Because we wanted to ensure that the testing as a new data set is consistent with our findings with the training. Okay? Murag ka ng ganina ba na ang old, ang training, ang testing is ang imuhang unsa. Mao man na ang way nato to evaluate whether or not our prediction is true over time. So we need to really actually do the percentage split. But for this class, we will use the training set muna as the default one. Now, after determining your test options, we need to know the classifier that we're going to use. So basically, that is found here by clicking choose. And then we have a lot of classifiers in here. So we have different classifications. Classifiers, we have the Bayes. Ang pinaka-common is BaseNet and naive Bayes. So ang pinaka-common is naive Bayes. So we're going to run our classifier using naive Bayes. We also have some functions here. Since ang ato ang variable is categorical in nature, then we can run logistic, we can run multi-layer perceptron, we can run simple logistics. So there are specific discussions here about those algorithms, and we also have SMO. So SMO is sequential minimal optimization. So we also have the lazy algorithm family. We have the LBK. This is K nearest neighbor. Tama ba ko? K nearest man is, yeah, it's K nearest neighbor, the LBK. And then sa meta, we have here bagging. Kato akong ginayon sa inyo kanina na the meta classifiers. We have the bagging, we have the CV parameter selection, we have the logit boost. But we're going to skip this now because this will be our lesson for next week sa atong face-to-face. So we're going to skip the meta classifier muna. We have the miscellaneous. Wala tayong pipiliin dito. For rules, we have the decision tree. Wala tayong, no, sorry. The decision tree is found in the trees, which is J48. We also have random forest and random tree. So ang ating pipiliin for this one is J48. Now we're going to select muna the naive Bayes or the naive Bayes as a classifier. So once you select the naive Bayes, you're going to click naive Bayes in itself in order for you to set it to its correct settings. So for one, titingnan natin dito kung use supervised discretization. Meron bang discretization na mangyayari? Naka-discretize na kasi tayo, so false lang ito. Mag-kernel estimator ba tayo? Hindi napakalaki yung ating dataset, so false lang din tayo. For 2 decimal places, okay lang ito. Do not check capabilities. So if set classifier capabilities are not checked before classifier is built and it is used, it can actually reduce the runtime of your software. So, ang gagawin natin dito is more of following just the default, and then we click OK. Afterwards, start. Okay? So, nakita natin dito na ito na yung ating classification for sepal length. According to ang average for iris setosa is 4.99. Ang sepal length, standard deviation is 0.35. Here's for iris versicolor and iris virginica. So kapag maliit masyado yung sepal length, then it's possibly na iris setosa ang kanyang classification. Kapag napakahaba naman, it's basically iris virginica. For sepal width, of course, ang pinakamalaking sepal is normally iris setosa. So gamay siya ang iyang kataas pero mas lapad, no? Compared with iris versicolor na mas taas compared sa iris setosa, pero mas nipis ang iyahang width, ang iyang sepal, kumbaga. For petal length, ang pinakadako is iris virginica, same as with the sepal length. So medyo dako-dako gid yung iris virginica, pero mas nipis ang iyahang sepal width. Pero ang pinakagamay nga petal is itong iris setosa. So makita nato diri ang we can actually see here the descriptive statistics for the attributes. And then, makita nato diri that whether our model has correctly trained, makita nato na 96% correctly classified ang ato ang mga flowers according to their classification. So this one is the confusion matrix. So ano ba ang confusion matrix? Ito ang mag-classify whether class A is really correctly classified as class A in itself. So for class A, it's iris setosa, and here in a confusion matrix, ang 50 iris setosa is correctly classified 100%. Now for iris versicolor, sa 50 kabuok, 48, according to the naive base, 48 lang ang iyahang na-classify nga iris versicolor gyud. And then, ang sa iris virginica is 46 lang ang yang correctly classified. Na ay mga upat diri nga gi-classify niya na instead na iris virginica, iris versicolor yang classification. Okay, so again, how do you select the classifier? You choose the classifier and you go to base first, and then click naive base, and then click naive base. Wala naman tayong settings na binago, so we will just click OK. And then using the training set, you start it. You start clicking that something. So 1 minute, and then type done if in case you're done. Ay, very nice. Ang bilis matuto ah. Sige, ngayon ang gagawin natin, hindi naman ito madi-delete, pero ito yung mga specific natin na mga results sa stats. No? So 96% ang kanyang classification accuracy. Mao ni ang yang mean absolute error, i-report nato ni siya, root mean absolute errors. Maghimo tag table ani kay daghan mo tag algorithm na ipang develop. So maghimo tag table ani na ang relative absolute error is 7%, mao ni ang average TP, FP, precision, recall, so 96%. Although almost close na siya sa 100%. So baka may other classifiers na better classifiers. So we're going to select another one. We will select the logistic. Logistic ba? Gamay lang. Hindi man siya binary, no? Although, di lang ta mag-logistic. Mag-ato lang tag-lazy. Now, ang lazy, daghan kitag settings ani kay K nearest neighbor ni siya. So, K nearest neighbor 3, 5, 7, and 9 atong i-run. Sige, for this one, we'll choose LBK. Okay. Then afterwards, we click that. And then KNN 3. Okay. Afterwards, click OK. Tapos start. So as you can see here, 96% si naive base, but si KNN3, 96.67%. So which is a better classifier comparing the two. So ang better classifier is the KNN3. Now, daghan man tag i-run nga kuan, daghan man tag K nearest neighbor na i-run. So of course, mag-run po ta, mag-simulation ta to KNN5. How are you going to do it? You go back to the classifier. Replace 3 with 5 and then click OK and then start. So 96% tinaog na pud ang from 96.67% tinaog siya mo. Murag same ra siya og percentage of accuracy with naive base. I-try na to siya gura na pud with 7. Start. So nitaas na po siya 96.67%. So another magkuha na po ta. K nearest neighbor of 9. Okay, start. So 97.33%. So 3, 5, 7, and 9. So saan dito ang pinaka-best? It would be
9.
9. Okay, so kung i-plot na mo siya sa graph class, kung mag-bar graph ka, makita ginatong ang pinakataas o correctly classified instances si KNN 9. Okay, so kindly run the 3, 5, 7, and 9 and type done KNN if tapos na kayo sa 4 na simulations. I'll get just water na lang.